equilibrium. The problem is a 20 kg sphere. This is a sphere. Rest between two smooth planes. Smooth plane, right plane and left plane. Determine the magnitude of the force acting on the sphere by the each of the plane. So we have to find the forces. So the each plane exert a normal force. So each exerts normal force. And this is normal force is perpendicular to the plane at the point of contact. So this is the, and this is the sphere. So this is the force, and this is another force. So this is a force, and this is right force. So we can write it Fr, and there is another one, which is F of L, and this is the point of contact. So this is right and this is left, and then there is an angle. So perpendicular, this is x-axis, and this is y-axis. So this is a y-axis, this is a theta right, and this is theta left. This theta is equal to this theta. So this angle is given. This is 30 degree and this is 70 degree. So theta r is equal to 30 degrees and theta L is equal to 70 degree. So if we have this one, this is F of right. This is theta r. So this is the x component. So frx, and this one is fry component. Y component. So sphere is equilibrium. That means all the forces 0. So we can resolve into fx and fy. So that means fx is equal to 0, and so sum of the fy is equal to 0. If you consider fx, sum of the fx is equal to 0. So this is fx. So this fx, sum of x component of x plus f left x component is equal to 0. This one is fr into, this is sine of theta right, plus similarly on this side is also this one, this, and this one. So this is on this negative side. So this will be negative sign. So negative sign. So f of L sine of theta left is equal to 0. So that means this left. So this means f of r is equal to sine of theta left. Left is 70 degrees over uh, no, if you simplify this one, f of r into sine of theta r is equal to f of L sine of theta L. So from here, f of r is equal to f of L into sine of theta L, sine of theta L over sine of theta r. So this is equation 1. Now sum of the y component is equal to 0. So this is up and other one is also up. So but there is a one component which is a mg. So this is a sphere and this is mg. So f of r cos of theta r plus f of L into cos of theta L minus mg is equal to 0. So mg is equal to, on the other side, so f of r, so f of r, we substitute this one here. So this is f of L into sine of theta L into sine of theta r into cos of theta r plus this term f of L into cos of theta L is equal to mg. So f of L is common into this one, sine of theta L over this one, tangent of theta r plus cos of theta L. This is equal to mg. M is known, and m is 20 kg. 20 kg. So from here, if FL is equal to mg over, this will go on this side, FL into tangent of theta right plus cos of theta left. If you substitute the values, then we will get FL, which is equal to 1.99.51 newtons, or we can say FL is equal to 1.0 into 10 to the power approximate 100 Newton. And if we substitute this value here on equation 1, then FR is equal to 99.51 into sine of theta L over sine of theta R. So here theta L is 70 degrees and theta R is 30 degrees. If you substitute these values, so then we will get 187.0 Newton, which is FR, and which is equal to 1.9 into 10 to the power 2 newtons. So this is FR. So this is FR, this is FL. So theta and the normal force which is normal. So this is right, this is left. Theta is right 30 degrees and 70 degrees. When is 30 degrees is force F right is 1.9 into 10 to the power 2 newtons. When is 70 is FL is 1.0 into 10 to the power 2 newtons. Conclusion, theta lower, F normal higher. So this result So only problem is that forces and then resolve, then state the condition of equilibrium and then separate and then substitute the value and then conclusion. What is the conclusion? Conclusion: smaller the angle, larger the force.